Now that you've got the idea of how to feel the action, let's learn to read a micrometer to an accuracy of 1/100th of a millimeter. Earlier in the program, we saw that the sleeve is graduated along the datum line in 5 millimeter steps, and that each step consists of 5 1-millimeter markings, which are in turn subdivided by half-millimeter markings. We then learnt that the full range of readings on the sleeve is 25 millimeters. Now, when a micrometer that has a range of 0 to 25 millimeters is fully closed, the reading will be 0. Notice that the 0 mark on the thimble is directly in line with the datum line, and that the edge of the thimble is aligned with the 0 mark of the datum on the sleeve. This then is the 0 reading. Turning the thimble anti-clockwise will reveal more and more datum line markings. And naturally, the gap between spindle and anvil will increase. Each small division on the thimble represents 0,01 millimeters. That is 1/100th of a millimeter. Turn the thimble by 1 small division, and you have increased or decreased the gap between anvil and spindle by 1/100th of a millimeter. There are 50 divisions on the thimble. Turn the thimble 1 full revolution, that is, say, from 0 right around to 0 again. You will now have altered the gap from anvil to spindle by 50 times 1/100th of a millimeter. That is 0,5 millimeters. If a micrometer was set at 0 and you turned the thimble by 1 full turn, the edge of the thimble would be in line with the first half-millimeter mark on the datum line. This reading then can be written as 0,5 millimeters. It follows that if 1 full turn of the thimble gives a reading of half a millimeter, 2 full turns will give a reading of 1 millimeter. If the micrometer thimble is rotated 50 full turns, the edge of the thimble would be aligned with the 25 millimeter datum mark, and the full 25 single millimeter divisions would be visible along the datum line. It is the visibility of the markings on the datum line that are important when we read a micrometer. Let's explain this step by step. We shall examine this reading as a typical example. First, we count the number of visible whole millimeter divisions. The 10 mark is visible plus 2 other full millimeters. Therefore, we can write down 12 as the figure before the decimal place. Now, as the thimble has not exposed another full millimeter, but is just exposing a half-millimeter mark, then it can be taken that a half-millimeter must be included in the reading. Further, you can see that the datum line is in line with the second division after the thimble 0 line. That is, by 0,01 divisions, which of course is 0,02. This is now included in our reading. Now, add up all the individual readings, and we get the full reading of 12,52 millimeters. Let's summarize on the reading of a micrometer. Firstly, remember that a reading is taken at the edge of the thimble. Consider first the visible full millimeters and half millimeters along the datum line and note them down. Next, read off the thimble the number of the hundredths of a millimeter that is in line with the datum line. In the example shown, the full reading is 5 plus 1/2 millimeter plus 48 hundredths. Adding up, we get 5,98 millimeters. Now, a lot has been said, and you've been shown the basic principles of how to read a micrometer. So, before continuing, we suggest that you get in some practice using a 0 to 25 type micrometer. A good way to start is to measure things for which you can obtain the standard manufacturer's size specification. Objects such as valve stems, gudgeon pins, thrust washers, and so on will be good examples. Check your readings against the given specifications. Practice until you consistently obtain the specified reading each time you measured the object. When you return, we shall discuss some important aspects regarding care and maintenance of micrometers.